So the derivative of a trig function, you mean like the derivative of sine? Yep, the derivative of sine. Now, the interesting thing is now that you're in calculus and you're kind of officially getting into what we know is the first branch of calculus. Remember, there's a calculus tree, and at the bottom are limits. Limits kind of get us to the tree, and we're talking about the one branch calculus right now. It's known as derivatives. Okay, and remember, a derivative is the same as a slope, because when I say derivative, you say slope. So in all seriousness, if I ask you for the derivative of sine, what I'm really asking you for, what I'm really asking you for is the slope of sine. Okay, now right now in my trig class, we're talking about sine, and maybe you can think back to last year when you talked about sine. Okay, it goes up and down. It's a sine wave. It's got slopes, doesn't it? It's got slopes. That means it has a derivative. Okay, now you'll find out something pretty magical about the derivative of sine. But to help you figure that out, let's have a sine wave, shall we? Here's a sine wave. And let's take some places on this sine wave and think about the slope. That's kind of random, but we'll take the slopes. Okay, I gotta fix some of the sound effects. Now you can kind of play along. You can I'm going to end up making a little discovery with you. You can just kind of watch. Make sure you're participating in some way. Maybe you want to participate by actually drawing a sketch that we're going to do here. But really neat, magical kind of discovery. You'll be glad you came today. Guarantee it. So let's take some slopes. Now I've kind of hand chosen some slopes so that it's easy for us to think about the slopes. So how about right there? Now that's pi over 2. Don't let the pi thing get you too worked up. That's the same as 90 degrees. But basically that point, that place, has a slope. I'm going to skip a space because we're going to go back to 0 in a second. We're going to go back to 0, but I'm going to start at pi over 2. And it's an easy answer, right? The slope of that line, everybody knows, is 0. 0. You'll catch on because there's just some other points along here that I want to talk about the slope with you. Here's a point. It's at pi. Now again, pi is just a place. It's actually the same as 180 degrees, but it's got slope right there. Now if you're like, should I know what that is? Might be able to make a good guess. Any good guesses on the slope right there? It definitely has to be negative, right? It has to be negative. Any good guesses? Okay, because that's all it would be if you would say negative 1. It's negative 1. Now, I didn't expect you to know that, but let's kind of agree, and maybe you're not too surprised that as you think about the way a sine wave goes up and down, that at that point right there, it's kind of perfectly tilted. It's perfectly tilted with a slope of negative 1. Let's find a couple other places because I want you to discover something. So there's 3 pi over 2. Of course, another slope of 0. And since I'm kind of leading the discussion here, I get to pick the points. That point out there is 2 pi. Basically at the end of the period. It's at the end of that first cycle. Now, any good guesses on the slope?
Positive 1.
Sure, positive 1. Now, this is why I didn't start at 0, because everybody would have been staring at me. But now that we go back to 0, we see that there's also a slope of positive 1. Now, there'll be a point where you're going to make a connection. That point might have been yesterday when you were making a connection between a position and a velocity graph. Some of you, that might still be kind of bad language, and you're like, I don't get that. But the truth is, you had a little bonus problem, and that bonus problem, you tried to look at a graph and think about the next graph. Okay? Some of you might make a connection today because we're going to do the same thing. And some of you might make this connection next week because you'll be doing a little hands-on activity. What's happening here is we're taking the derivative of that graph and we're going to graph it. We're going to graph the derivative of sine. What do you mean we're going to graph the derivative of sine? Well, we're literally going to graph these points. These points represent the slope of sine. So again, just to say it again, we're going to graph the derivative. Now, just in case you kind of lost me, that was what we were trying to figure out about 5 minutes ago. What's the derivative of sine? We're about ready to graph it. Okay, now, if something occurs to you in the next 30 seconds, try to contain yourself. Don't call it out, because I want everyone to have a chance to kind of notice something. But we're going to graph 0, 1. Boom. We're going to graph pi over 2, 0. Okay, we're just graphing these points. It's just a sketch. Now, again, if you notice something, try to contain yourself. I know it's pretty neat. Remember, we're graphing the derivative. We're graphing the derivative. Looks like just some points, eh? It's not just some points. It's the derivative. It's fine if you... No problem. To help you get a little closer to the magic moment here, we connected the dots. We can connect them with a solid line too. I just didn't want to make it too obvious yet. We're graphing the derivative. You realize what we're graphing?
Cosine?
Would it be cosine? Okay. Indeed, that is cosine right there. So, well, what does that mean? What does that mean for the derivative of sine? The derivative of sine is cosine. The derivative of sine is cosine. Literally, the slopes of the sine wave, the slopes of the sine wave are the cosine wave. The derivative of sine is cosine. Pretty neat. Aren't you glad you came today? Okay, now if you think that's neat, or maybe if you don't think it's neat, all the trig functions have a connection. All the trig functions have a derivative connection. What I mean is the slope of all the trig functions relates back to another trig function. So the derivative of sine is cosine, but the derivative of the derivative of cosine is negative sine. And the derivative of tangent is secant squared. And the derivative of cosecant is negative cosecant cotangent. The derivative of secant is secant tangent, and the derivative of cotangent is negative cosecant squared. Now, what I'm showing you here is a set of rules. It's a set of rules that show you or tell you the slope of each trig function. I'll let you jot them down. Be careful that you write them down correctly. They are in the book, but they're kind of scattered. So unless you're going to look in the book, just carefully get all the components of these. As you write these down, each one of them represents a slope connection. Just like I proved that the derivative of sine is cosine, you could do that for each one of these, although it's a little more complicated, and we won't, but it's the same connection. Now, I had a biology teacher in high school, and this is also really weird. Actually, bless you. You know how the brain is quite a complex organ. I actually had a dream about him last night. It's just weird. I saw him in like a coat and tie, and I kind of was like, why are you wearing a coat and tie? I actually, again, just thought about I don't know if it's because I was thinking about this lesson. I really wasn't. Maybe my subconscious I was. But anyway, I had a biology teacher. He was really a great teacher, kind of like made his students work hard. And we had to memorize a number of things in biology. Some I have forgotten, but one I'll never forget. It's kingdom, phylum, class, order, family, genus, species. And we had to say that really quickly. We had to say kingdom, phylum, class, order, family, genus, species. Now, I think that that's kind of like the breakdown of like all living things, kind of like, I kind of forget what it is. Can anybody give me some help here? It's kind of like the breakdown structure of kingdoms, or is it the animal kingdom? I think it's all things that are alive. Okay, so anyway, in honor of my biology teacher, because it was a really good way for me to memorize something, I'm going to have you also be able to very quickly and verbally and out loud as a grade, you will also rattle off these rules. You will say the derivative of sine is cosine, derivative of cosine is negative, sine, the derivative of tangent is secant squared, the derivative of cosecant is negative, cosecant cotangent, derivative of secant is secant tangent, and the derivative of cotangent is negative cosecant squared. And you will rattle off those rules, maybe not quite that fast. I'm a little gentler than my biology teacher from 20 plus years ago, but you're going to verbally say them as a way to help you memorize them. Now, maybe for some of you, it'll be like, that's cool, I'll do that. Some of you, it might increase your blood pressure a little bit. I get all that. But ultimately, you're going to say them out loud, and you'll say them comfortably and correctly, and you'll get some points for it. I'll share that the way that this works is over the next 3 days. That's either Wednesday, Thursday, or Friday. You'll just be like, hey, Miss Naylor, I'm ready to rattle off the rules. And I'll sit and smile, and you'll either come over to my desk, you'll stay at your seat. Some people like to look at the ceiling. And some people, if it really, really is kind of stressful, they want to do it when like the kids leave the room, and I'll let you do that, but you'll rattle off the rules. Okay. By the way, everybody else is rooting for you, and usually people kind of are happy for you when you get them right. Okay. You'll be able to do that tomorrow, Thursday, or Friday. Okay. Which, again, I give you some flexibility. Practice them, and then practice them again, and practice them a few more times. You have to memorize these rules. I promise you'll need them all year. You'll need them all year. Okay. Thoughts on the little rattle off the rules? All right, it'll be fun. It's points. It's usually points that people get. I'll even do this. Don't tell my biology teacher. But if you get it wrong, we'll just kind of say, stop. And you may return to your seat. You can take a deep breath, but you'll get 2 tries. You will get 2 tries. Okay, I want you to get them right. I also would like you to realize why they're true. So what I'm going to do is I'm going to prove to you that the derivative of tangent is secant squared. Okay, so we're going to do like a little proof. This isn't just kind of fluff and stuff. This is actually skills that I want you to have in your assignment. You actually will prove another one of these using a similar strategy. Okay, now just the word proof or prove sometimes also raises students' blood pressure. It doesn't have to be a bad word. I'm not sure when it became a bad word, but a proof is really just showing through basically algebra or analytical techniques why you can start with tangent and end up with secant squared. Now, the thing that's kind of weird here is that, okay, we're going to start with the derivative of tangent, but, where do I go from there? Am I allowed to use one of these rules? Okay, well, you'll learn that, yeah, we can use one of the rules if we already proved it. Now, we already proved that the derivative of sine is cosine. Do you see a sine when you look at tangent? Do you see a sine? It's almost Halloween. And when tangent is in his Halloween costume, it dresses up as a what? It dresses up as a quotient. It dresses up as a numerator over a denominator. Now, if you're like, I don't get it, Miss Naylor, just give me some candy. This is from last year. Tangent is equal to blank over blank from last year. I had some of you last year. Go ahead.
Would it be sine of x over cosine?
Good. It's sine over cosine. Remember my first identity book? Okay. I told you you're supposed to read that every night before you go to bed. Some of you have to dust that off. If you didn't make my first identity book, see me at the end of the period. We'll make the book. Now, the derivative of tangent then is the same as the derivative. I should clean up my notation a little bit here. The derivative of sine over cosine. Okay, now this is okay because we already proved that the derivative of sine is cosine. And what we'll say is that we already proved that cosine is negative sine. We could have proved it the same way. Here's what I really want you to realize. This, ladies and gentlemen, is a quotient. You're going to need to get this, and you will get it, but to do the derivative of a numerator over a denominator, we have to use the quotient rule. We have to use the quotient rule. So the quotient rule says that the derivative of sine over cosine would be the derivative of the bottom, or excuse me, it would be the bottom times the derivative of the top. And make sure you're thinking here, because the bottom times the derivative of the top is something that you can write down. The derivative of the top is cosine. So we have bottom times derivative of top minus, need a little more space here, minus the top times the derivative of the bottom. Okay, now the derivative of the bottom, we're going to say that we proved that already. Okay, because the derivative of sine is opposite cosine. Excuse me. Hold on a second here. I'm getting myself mixed up. Bottom derivative of the top minus top derivative of the bottom. Derivative of the bottom. My mistake here, that the derivative of cosine is negative sine. And remember, it's all over the bottom squared. It's all over the bottom squared. Now, something else kind of magical is about ready to happen. I don't know if we can pack all this stuff into one lesson, but we're going to, because if you look at the numerator, you get cosine squared. If you continue to look at the numerator, you get sine squared. I know it's hard to take your eyes off of it. It's just kind of one of those things that you just keep staring at it because it's so wonderful. Sine squared plus cosine squared. Just look at that, sine squared plus cosine squared. Or maybe listen to that, because remember, sine squared plus cosine squared equals 1. Good, we even got a little smile because sine squared plus cosine squared is the Pythagorean identity. And remember, if you see me at Lowe's, you need to be able to say, hey, Miss Naylor, sine squared plus cosine squared equals 1. One over cosine squared. 1 over cosine squared. Another identity. Okay, whenever you have 1 over cosine, by definition, that's secant. If it's over cosine squared, then it's secant squared. And don't look now, but we just proved it. We just proved that the derivative of tangent is secant squared. Isn't math neat? Okay. All 6 of those definitions could be proved. Now, some of them are a little bit beyond the scope of our class, but you get the idea that we didn't just pull these out of thin air. The derivative, the slope of a trig function is a trig function according to these rules. Okay, it's a good stopping point, but we'll do some more derivatives. We'll kind of use these rules. Maybe you want to practice memorizing them at lunch, or maybe not.